This video will be about proving and applying Pythagorean theorem. So for this first display, I'm showing 3 different highlighted triangles. And as we know with similar triangles, we have corresponding sides that are proportional. So I've already set up my proportions and I highlighted underneath which triangle I was referring to. So the bigger one is highlighted in blue, and then the 2 smaller ones are purple and yellow. And the numerators of each of those proportions are representing the hypotenuse, whereas the denominator is representing the leg. So in the first one, if I were to cross multiply, a times a is going to be a squared, and then the other way, c times e is going to be ce. So a squared can be replaced with ce because it says it's equal to that. And on the other side, if I do the same thing, b times b is b squared, and c times f is CF. So if I'm looking at my Pythagorean theorem, I see that I have an a squared and I have a b squared. Well, I'm going to replace that with the CE and the CF. And once I do that, I can now factor out the greatest common factor of C. And that's going to leave me with C times the quantity of E plus F. And if I recall, segment addition postulate says E, so I'm looking over at the figure now. So E, segment E plus that segment F is going to give me the entire segment C. So that's segment addition postulate, which means that I can now replace the C times the quantity of E plus F with C times C, which is really C squared. So I have now proven my Pythagorean theorem. So now we're going to apply it. This example gives us numbers now. It gives us more information. We didn't have this a few minutes ago. So what I want to do is I want to break apart the triangles and I want to find the values for C, E, and F. I personally would suggest that you go ahead and write that formula out and then you go ahead and substitute what you know. So your C squared is always your longest side. That's your hypotenuse. If you don't have all the information, then you're looking for the larger number. Or if you understand how the hypotenuse works, it's always across from your right angle. So if we're trying to find C, C is going to be this long side. So I'm looking at the big triangle. And I notice that my right angle is where H is located. So what I'm going to do is look directly across from it. And when I do that, I see, oh, C is my actual hypotenuse. So what I'm going to do is go ahead and use the other information for my legs. I have a 15 and I have a 20. 15 squared plus 20 squared, and that's going to equal C squared. Well, I understand that C squared, I don't want C squared, I want actually C. So I'm going to go ahead and take the square root of both sides, and that's simply going to give me C is equal to, well, I still have to simplify what's underneath the radical. So I have 15 squared, and all of this is still under the radical. That's 225. And then I have 20 squared, which is 400. I'm just going to use my metric property of equality, and I'm just going to change this around. So C is equal to the square root of 625, and therefore C is going to equal square root of 625 is 25. So that's my value for C. This whole side is 25. So now I want to go ahead and find E. Well, for E, I'm only looking at this triangle. And again, I notice directly across from my right angle is my hypotenuse, which is 15. So I can go ahead and fill that in. So I am going to put 15 squared on this side. And what else do I know? I know that I have a leg that's 12, and then I don't know what E is. That's what we're trying to find out. Again, it doesn't matter which comes first. If I just wanted to do 12 squared plus B squared, or if I want to say A squared plus 12 squared, it's still the same thing. It's just like 5 plus 4 and 4 plus 5 still equals 9. All right, so now simplifying this, I have 12 squared, which is 144, plus B squared is equal to 225, and B squared is equal to, well, I want to change signs once I move this over. So 225 minus 144 is 81. And then I'm going to do the same thing to get rid of the square. I have to take the square root, and the square root of 81 is plus or minus 9, but however, you can't have a negative length. So we're simply just going to say B is 9. Well, B was really representing E. So E is equal to 9. Okay. And now we're going to go on over to try to find the value for F. And this time we're looking at this triangle. Now notice we don't see that right angle mark, but if this side is 90 degrees, by default, this side has to be 90 because a straight line equals 180. So this is what we're working with. And what we know is directly across from the right angle symbol is our hypotenuse. So we know that's 20. And then we have a leg that's 12, and we don't know what the other leg is. So let's fill that in. This time we're going to say A squared squared plus 12 squared is equal to, and then we said the hypotenuse was 20. So 20 squared. We're going to simplify and we're going to go ahead and subtract that 144, which is 12 squared, on the other side. So 20 squared is 400 minus 144. And then a squared is equal to 256. Now I need to get rid of this square. So I'm going to square root both sides, and which leaves me with a. A is the square root of 256, which is really 16. 16 times 16 is 256, but we were looking for f. So f is really 16. So this is how you apply Pythagorean theorem to find the values for C, E, and F. Example 2. Cameron and Francisco were trying to decorate a house when they decided to use a 20-foot ladder. They placed the ladder diagonally against the side of the house. The bottom of the ladder was 3.5 feet from the house. Diana and Samaj came by and asked them how many feet above the ground did the top of the ladder reach. They glanced at each other and then raced to see who could figure it out first. So what I would suggest is that you go ahead and draw a depiction of what you think the word problem is saying. And based off of what we were given, we know that they're using a 20-foot ladder, but we need to know, where does it go? Does it go up and down, horizontally, or diagonally? Well, think about a ladder. When you place it against the house, it's diagonally. So therefore, the 20 has to go for the hypotenuse. How do I know it's the hypotenuse? Because the ground and the house create a 90-degree angle, and we already know that that 90-degree angle, the symbol that's shown there, the hypotenuse is going to be directly across from it. So keep that in mind always. Then we're given more information. It says the bottom of the ladder was 3.5 feet from the house. So the bottom of the ladder and the house, that's horizontally. So that has to be on the ground, not the ladder itself, but just the bottom of it. And so when Diana and Samaj came by, they wanted to know how many feet above the ground. So if this is the ground, they want to know how far above. Well, we're going up and down. That's vertically. So therefore, we're looking for that side or that leg that's vertical. Now that we have the information we need, we can use the Pythagorean theorem and substitute. So for A and B, those are interchangeable. Those are your legs. You can either put x squared plus 3.5 squared or 3.5 squared plus x squared. It does not matter. I'm just going to go ahead and do the x squared plus 3.5 squared, and then the C, which is going to be my hypotenuse, is 20, and everything is squared, so pay attention to that. So x squared plus, once I simplify 3.5 squared, that's 3.5 times 3.5, that is 12.25. And then 20 squared is 20 times 20, which is 400. At this point, I want to subtract 12.25 on both sides, so I'm left with x squared is equal to 400 minus 12.25. And once I simplify that, 400 minus 12.25 is 387.75. However, I need to get rid of the square, so I take the square root of both sides, and f is approximately 19.7. So I want to go to the tenths because I look at my other leg and I see that it was actually to the tenths as well, so that will make more sense. Don't forget to like and subscribe. Have an awesome day.